Hey guys, welcome back to my channel and on the series of what on binomial theorem. So we're checking out how to expand negative powers of binomials. Whenever you have something like this, so let's assume you have a plus b raised to power minus 2. How do you expand it? Whenever you have a plus b raised to power minus 1, how do you expand it? How do you expand a plus b raised to power minus 10? So all these can be what? Can be expanded using what? By using this expanded form. So on to the negative integers. Whenever you are using negative integers, you don't use the closed form, you use the expanded form of what? Of the binomial theorem. So this is what we call the expanded form of the binomial theorem. This is called the expanded form. Expanded form. This is what we call the expanded form of what? Of the binomial theorem. So this is a binomial theorem for the what? Negative integers. Whenever you have negative integers, you use the expanded form. This is the expanded form. And let me say this. The number of terms in an expanded form is infinite. It's infinite. That means this number of terms continues to infinity. It continues, you can see dot dot. All these dots you see are what? Are going on to what? To infinity, because they are an if number of terms. Good. And this expansion works for two things. It works for negative integers 1 and what? 1. Expanded form. So let me write it down. Expanded form is used for 1. Negative integer powers. Negative integer powers. 2. Fractional powers. So these two are what we use expanded form for. So whenever you have this, you use expanded form. Whenever you have fractional power, other fractions like 1/2, like a 1/2, like a 3/4. These are what we call the fractional powers. Whenever you have that, you also use the word expanded form. Let's go to an example. So using that expansion, let's take an example. Let's assume I have x plus 2 raised to power minus 1. How did I do it in expanded form? It's x plus 2 raised to power minus 1. That equals what? That equals x raised to power minus n. So you have x raised to power minus n, x raised to power n. Can you see that? Then you have what? Minus 1. So the power here is n. You can see your n is minus 1, your n is minus 1. And yeah, your a is x. So that is x minus 1 minus 1. Your n is minus 1. N. Put 1 here. Minus, take a 1 from there. Then your b. Your b is what? Is 2. That is 2 raised to power 1. Can you see that? Next time you have what? You have minus 1 times minus 1 minus 1 over 2 factorial. Can you see? And you have x. N is minus 1 minus 2. Can you see? And you have a what? You have a 2 raised to power 2. So you subtract 1 from this, you decrease by 1. Subtract 2 from this, you decrease by 2. Or you increase that by 2. Next you have minus 1 minus 1 minus 1 minus 1 minus 2 over 3 factorial. And here you have minus 1 minus 3. And you have what? 2 raised to power 3. You can see you have a what? No! You can't find the total value of this. You can't find it. But you can what? you can find an approximate or a certain number of terms because you have an infinite number of terms. So for the case of this video, I'll be showing like the first 4 terms of the what of the expansion because you have an infinite number of terms that continues forever. So you can just take a finite number, let's say like 4 terms, like 3 terms, just to know the number, to know the certain terms or the patterns in the expansion. So in that case, I can clean this off. Good. Now we know. So concerning this is what x to the power minus 1, and here, what do you have here? You have minus, this minus, you have x to the power minus 2, can you see? And you have a what? Times 2. So you have a 2 here, can you see? Next one, you have a what? A minus 1 and a what? A minus 2 over 2. 2 factorial means 2. 2 factorial means 2. 2 factorial means 2. And you have what? X to the power minus 3. And what? And you have a 4. Let me put it. You have a 4. Can you see? 2 to the power 2 is what? Is 4. Next one, you have a what? You have a plus. You have a minus 1. A minus 2. And a minus 3. What is 3 factorial? 6. So you have a 6 here. And you have a what? X to the power minus 4. Okay, I'll be cleaning this off. So I have a plus, minus 1, minus 2, and minus 3. You can see minus 1 minus 2 is minus 3. Minus 1 minus 1 is minus 2. Minus 1 here. What is 3 factorial? 3 factorial, note. 3 factorial means 3 times 2 times 1. You can see 3 times 2 times 1. That is the meaning of 3 factorial. So that means here, what is 3 times 2? 6 times 1 is 6. Can you see that? Here you have a what? X to the power minus 4 and a what? And 8. And you have an infinite number of terms. It doesn't have an end. So therefore you have x to the power minus 1 here. Can you see that? Of x to the power minus 1. Then from there you have minus 2. Minus 2. You have x to the power minus 2. Can you see that? Next one you have a what? Okay, this cancel this. So you have a plus here. You have a 4 here. So you have a 4 x to the power minus 3. Can you see that? And yeah, this 3 and 2 cancel this. 3 here, 2 cancel this. Can you see? And you have a 1, but you have a what? A minus left. And you have an 8 x to the power minus 4. And that goes on forever. So you can see that this has a what? Has a particular pattern. In fact, this has a particular pattern. The pattern is powers of 2. You can see there's a power of 2 here. Powers of 2, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, like that. So that's how you what? How you expand the what? The negative values of what? Of binomials. Sorry. You can do this in both ways. You can write the 2 here, you can write the x here, and that gives you another form. Let's try that out. This same thing can be expanded in another form. This stuff can be written as 2 plus x all raised to power minus 1. 2 is here, x is here. Let's do the same thing. That means here you have 2 raised to power minus 1. That's what you have there first. Next one you have minus 1. Can you see that? And you have what? 2 raised to power minus 1 minus 1. You take 1 from 8. Then you have what? X raised to power 1. Can you see? Next one you have minus 1 and minus 2. Okay. Minus 1 minus 1. over 2 factorial. You have minus 1 minus 2 x raised to power 2. What am I using? I'm using the formula of what? Of n minus 1 over 2 factorial. Let's say a raised to power n minus 2 and b raised to power 2. That's what I'm using here. My n here is what? Is minus 1. My n is minus 1. You can see I put minus 1 here, minus 1 here, and you can see over 2 factorial, minus 1, minus 2. My a is by 2. In this case, my a is by 2. My b and this, my b is what? It's x. So that's how you expand negative integers of binomial. So I can take this, I can say, okay, minus 1, minus 1, minus 1, minus 1, minus 2, over 3 factorial, 2 raised to power minus 1, minus 3, and x raised to power 3. Can you see? And I can, that goes on what? Forever. Goes on forever. So you have 2 to minus 1 here, you can have minus 1 here. This is minus 1 minus 1 is what? Is minus 2. So you have 2 raised to power minus 2. And you have an what? You have an x here. Can you see that? All about this. This gives us what? This gives us 2. So you have a minus 1. This gives us a minus 2 over 2. 2 cancel 2. Minus and minus gives us what? A plus. So in that case, I have a plus. I'll leave it like this. And you have a 2 to power minus 3 x raised to power 2. Can you see? What about the last one? Last one will be what? Last one will be minus 1, minus 2, minus 3 over 3 factorial. And that gives us what? That gives us 6. So 3 cancel this, 2 cancel this. 3 here, 2 cancel this. Can you see? And you have a what? 2 raised to power minus 4 and x raised to power 3. Plus plus. So that's how it works. So you can see now you can put it in the final form by having this. So that means 2 plus x minus 1 can become, this can be written as 1 over 2. This can be written as 1 over 2 squared. Can you see? And this can be written as x squared over 2 raised to power 3. Because note 2 raised to power minus 3 equals to 1 over 2 raised to power 3. So therefore, this can be written as this. This is not a big deal. What about this? You have a minus left. Minus is left because minus and minus is plus. That is minus. That's a minus. So you have a minus here, and you have x raised to power 3 over 2 raised to power 4, and you have a what? A continuous infinite terms. So you can see you have a what? A different pattern from the former one, but they're integer on the same method. So in negative integers, you can what? Can get it in what? In 2 ways. But most importantly, you have a what? An infinite number of terms. Let's check out a new one. Let's check out this. Let's check out this. Number 2, 1 over 1 plus, let's say x minus x. How do you solve this? Very good. Using the binomial theorem, you can do that. That becomes what? That becomes 1 minus x all raised to power minus 1. So my n is what? Is a minus 1. Then I can expand it using the formula. What is the formula? The formula says if I have a plus b raised to power n, that's a raised to power n plus what? N, a raised to power n minus 1, b raised to power 1 plus n times n minus 1 over 2 factorial, a raised to power n minus 2, and you have a b squared, right? And you have a what? A continuous number of terms. So in that case, I can expand this because I know my n is equals to minus 1. So in that case, this is my a. My a is equals to what? 1. My b is equals to minus x. So in that case, you have a 1 raised to power minus 1. Can you see? And you have a plus of what? Minus 1. This is the formula n a raised to power n minus 1 b raised to power 1. So you can see I have a, my a is 1 raised to power minus 1 minus 1. Can you see? Minus 1 minus 1. And you have b. Your b is what? It's minus x raised to power 1. Can you see that? Next time you have plus. Next time will be what? Next time will be n times n minus 1 over 2 factorial a raised to power n minus 2 times b squared. So you have a minus 1 minus 1 minus 1 over 2 factorial. Can you see that? A is power n minus. What's your a? Your a is 1. A is 1 minus 1 minus 2. And you have a what? A minus x raised to power 2. Can you see? So then you have a what? A continuous infinite terms. So what is 1 raised to power minus 1? 1 raised to power minus 1 is equals to 1 over 1, which is equals to 1. So that means here is just a single one. Next one here you have 1 raised to power all of this is 1 times minus 1 minus 1 times the minus, that gives us the plus, but ordinary x. Can you see that? You can try it out. Next one is what? Next one is minus 1 minus 2 over 2. 1, this one will be 1 raised to power minus 3. And this one will be plus x squared. Because minus raised to power 2 minus 1 raised to power 2 minus x is equals to minus x times minus x. This becomes plus, and you have what? You have an x squared. So that means this is what just an x squared alone. So that means yeah, to cancel this and this, and you have a what? You have a plus, and you have a what? You have an x squared and a continuous number of terms. So now, if you expand this infinitely, actually 1 over 1 minus x is equals to 1 plus x squared plus x cubed plus x raised to power 4 plus x raised to power 5, like that till infinity. Thank you guys.